Good morning, students. Today we will discuss about electric charge, electric potential, heating effect of the electric current and electrical power, etc. We know there are two types of electric charge. One is your positive charges and another one is your negative charges. Like charges attract each other and unlike charges repel each other. These are the properties of charges. Generally, we denote charge by a symbol capital Q or small q. And what is the unit of charge? That is your Coulomb. C-O-U-L-M only. Or in short form, we can write down Coulomb. So this is the unit of charge. Now, what is electric current? Already you have studied in class 6th, 7th, 8th and 9th about your electric current. So, electric current, which is denoted by a symbol I. Now, we can define electric current I is equal to Q divided by T. What does it mean? Q is the amount of charge and T is the time period. So, electric current is defined as the amount of flow of charge in T seconds. T seconds means maybe time period is your 1 second, 2 seconds, 3 seconds, 4 seconds and so on. Now, what is the unit of current? Unit of charge is your Coulomb and time period is your seconds. So, Coulomb per second, that is called as your ampere, which is denoted by a symbol capital A. Suppose we take a circuit. What do you mean by electric circuit? The closed and continuous path of an electric current is called the electric circuit. Suppose this is a conductor and this is connected to a cell. In a cell there are two terminals. One is your positive terminal and another is your negative terminal. Now, what does it mean? Positive and negative means what? We will discuss. Now, mark this conductor. Suppose A, B. Now, when the cell is connected to the circuit, first of all, this is a closed path. And if the current is flowing through the circuit, then this is called the electric circuit. If we disconnect here, then this is not a closed path. And at that time, we can say this is not a electric circuit. So, suppose this is a conductor. When the cell is connected to the circuit, then the free electrons will move from the negative terminal to the positive terminal. Observe the diagrams. When the cell is connected, then the free electrons will move from B to A, means from negative terminal to positive terminals. Now, negative terminal means, in other words, we can say here the potential is low, and positive terminal means potential is high. That means you can say that the free electrons will move from lower potential to higher potential. But in case of your water, suppose we consider two beakers. And the water levels are same. Suppose this is beaker 1, A and B, or 1 or 2. And a pipe is connected here. Then how can you find out the potential will be higher at A or B? We cannot say anything about the potentials of beaker A and B. If we uplift the beaker B, suppose, that means now suppose the beaker is here, water level is same, and pipe is connected. Then you can clearly observe the potential of B is at higher potential and the potential of A is at lower potential. Then water will flow from beaker B to beaker A. That means the water will flow from higher potential to lower potential. Now clear? What do you mean by potential? Similarly, in case of your temperature or heat, the same process will follow. Temperature will also flow from your higher potential to lower potential. Now, for this convention, to maintain this convention, we will consider the direction of electric current will flow from higher potential to lower potential. But according to this diagram, the free electrons will flow from B to A. That means from lower potential to higher potential. Remember one thing. At the discovery of your phenomenon of electricity, electrons were unknown. So, by convention, we will consider the direction of electricity as the direction of the positive charges. Generally, we denote by the electric potential by the symbol B. So, electric potential can be defined as your V is equal to W by Q. That means what is your W? W is the amount of work done. So, electric potential can be defined as the amount of work done per unit positive charge. That is called the electric potential. If we write down electric potential difference, difference means at least we have to consider 2 points. Suppose this is your A point and this is B point. And the potential potential at A is denoted by your VA, V subscript A, and at the potential at B, that is your VB. So potential difference means the amount of work done to bring the unit charge from one point to another point. Maybe the charge will move from point A to B or from B to A. So the electric potential difference is defined as the amount of work done in bringing a charge from one point to another point. But the unit will be same because the formula is same, W by Q. So joules per coulomb. So joules per coulomb, that is called as your volt, according to the name of the scientist Alexander Volta. So the unit of potential or potential difference, both are same. But remember one difference when we are saying about the electric potential or simply potential. At the time you have to find out the amount of work done in bringing a charge from infinity to a particular point. Maybe you are to a point A, B, C, etc. But when we are saying about the potential difference, at the time the amount of work done from one point to another. So this is all about your electric potential. Now, when we are saying about any electrical circuit, different components can be used and they have different symbols. Just like your bulb. This is the symbol of your bulb. This is the symbol of your cell. These are your connecting wires. One is your positive and negative. If we are connecting a number of cells, then this is called a battery. Similarly, this is the symbol for your resistance. Now, I will tell you two different instruments. A, positive, negative, and second one is written as your V. A means your ammeter, which is used to measure the current. And V means your voltmeter. Voltmeter, that is also a type of instrument which is used to measure the potential difference. So, in any circuit, if we want to measure the amount of flow of current, then we have to use your ammeter. And if you want to measure the potential difference, then voltmeter is connected. Now, how will you connect ammeter or voltmeter in any circuit? Remember, ammeter is connected in your series. In any circuit, ammeter is connected in your series, and ammeter has low resistance, whereas your voltmeter is connected in your parallel and it is high resistance. What do you mean by series connection? Series connection means if we are considering a circuit consisting of a bulb, suppose this is a bulb, and an emitter. A means emitter and cell is also connected. That means the one terminal of the bulb is connected to the one terminal of the cell and another terminal of the bulb is connected to the emitter. Means they are continuously connected. So this type of connection is called as a series connection. If we connect a voltmeter here, that means emitter, bulb and cell, all three components are connected in a series, 1 to 1 terminal. But at this point, suppose at the point P and Q, these are your two common points where these components are connected and the voltmeter is also connected. Here same, at the point Q, all these three are connected and the voltmeter is also connected. So this type of connection is called as a parallel connection. Okay, later we will study about when the resistors are connected in series and a number of resistors are also connected in a parallel in details. Now, suppose the current is flowing through the circuit. When current is flowing through any circuit, at that time the temperature will also rise. That means, in other words, we can say that the heating effect is also produced. Heating effect will be observed. That means some amount of heat will be developed across the circuit. Now, this amount of heat will depend on which factors? If we denote the amount of heat by symbol H, then you can write down H is equal to I square R T. What is your H? H is the amount of heat. I square of the current. I square. R is the resistance. And T. T is the time period for which the current is flowing across the circuit. Now, this formula or this law is called as your Joule's law of heating effect. Clear? So, according to this formula, we can write down H is proportional to your I square, square of the current. H is also directly proportional to your R, and H is directly proportional to your T. That means if you increase the amount of current, then the amount of heat will be developed. That means if we increase the current in any circuit gradually, then the temperature will also increase, as a result of which the amount of heat produced will also increase. Similarly, if you increase the resistance, then your heat will also increase. If you increase the temperature, same, then the current will also increase or temperature will also increase and heat will also increase. So, this is all about your Joule's law of heating effect. Now, what are the applications of heating effect in daily to day life? We all use electric iron, water heater, water geyser, etc. And in these appliances, heating effect is observed. Another important thing in our electrical circuit, fuse wire is also used, and in this case also your heating effect can be observed when the amount of electric current is overloaded or excess. At the time the wire of the fuse will melt so that the other appliances will save. That means there will be no damage to the other appliances. So here also we can observe your heating effect. Another application in your electric bulb, the filament, which is made of your tungsten material. When we switch on the bulb, then the electric current will flow and the heating effect will produce. But the filament will not melt because it is made up of the material tungsten, which has your high melting point. But we can observe the heating effect. So these are the appliances or these are the situations where heating effect can be observed in our daily to day life. Now, another important topic. Suppose we are considering a bulb of 100 watt. Now what does it mean? 100 watt. What means how much energy the bulb consumes. That is called the power of the bulb. Or we can say कि power is equal to work by time. Already you know, power of any object is defined as the rate of doing work. Means the amount of work done in t seconds or the amount of work done in 1 second, etc. So instead of work, you can write down your energy also. So energy by time. Now, what will be the unit of power? Unit means, what is the unit of work? Joules. And what is the unit of time? That is your seconds. That means, if 1 joule of work is done in 1 second, that is called as your power, and it is expressed as your watt. So if it is written like this, 100 watt means the power of the bulb is your 100. or in other words you can find out what will be the energy of the bulb. So the different units of power are, one is your watt, second one is your kilowatt. Kilowatt means we can write down 1 kilowatt is equal to 1000 watt. Similarly, megawatt, MW, 1 megawatt is equal to 10 is to power 6 watt. Another unit is your horsepower. 1 HP means 1 horsepower is equal to 746 watt. But the SI unit of power is watt. So P is equal to W by T. Again we know W is equal to V is equal to W by Q. So W is equal to V into Q. V into Q divided by T. Now we can write down P is equal to Q by T is equal to how much? I is equal to Q by T. Q is equal to IT. So Q by T is equal to IT. That means we can write down P is equal to V into I. So electric power can also be defined as the product of the potential difference and current flowing through the appliance. Now we can find out by using this formula. Suppose the bulb is your 100 watt and we use for your 5 hours. That means time period is your 5 hours. Now find out the energy consumed by the bulb. So P is equal to W by T or E by T. If you cross multiply, then we can write down E is equal to P into T, or E is equal to, now you can put the value of your P, that is equal to 100 watt and time, which is your 5 hours. So you can find out the energy is equal to how much. Here remember one thing, generally we use the unit of power is watt, but if you take the power in your kilowatt, kilowatt means like your kilogram gram, that means 1 kilowatt is equal to 1000 watts, and at that time will be in your hours, not in your seconds. At that time, the unit of energy will be your kilowatt hour. Clear? If power is taken in your kilowatt and at that time will be expressed in your hours, then the unit of energy will be equal to P into T. So kilowatt into hour, or it can be written as your kWh, means kilowatt hour. Now this kilowatt hour is also called as your unit, and this is the commercial unit of energy. sometimes maximum students write down kilowatt hour as the unit of power, but this is the unit of your energy because time means hour is also multiplied with your power. So this is the commercial unit of energy. Already we know the other units of energy are in MKS joules and in CGS ergs. In MKS the unit of energy is equal to joules and in CGS that is your ergs. Now if the question is what is the relationship between the MKS unit and commercial unit of energy? Clear? So MKS unit of energy is joules and commercial unit of energy is your kilowatt hour. That means indirectly you have to find out 1 kilowatt hour is equal to how much joules. So instead of 1 kilowatt hour, we can write down 1 kilowatt multiply 1 hour. Now convert 1 kilowatt into watt, that is equal to 1000 watt into 1 hour. 1 hour is equal to 3600 seconds. So if we multiply watt second, that is equal to joules. So that is equal to 136. We can multiply directly. 36 into 10 is to power 1, 2, 3, 4, 5. 10 is to power 5 joules. Or we can write down if we multiply 10 and divide 10. So that is equal to 10 is to power 5 into 10. That is equal to 10 is to power 6 and 36 divided by 10. That is equal to 3.6 into 10 is to power 6. So 1 kilowatt hour is equal to 3 into 3.6 into 10 is to power 6. Clear? So this is the relationship between your MKS unit of energy and commercial unit of energy. Now using this we can find out the electrical energy of different appliances, or you can prepare an electricity bill. How can you prepare your electricity bill? In your electricity bill, it is written as your total units is equal to this much, maybe 200 something or 300 something. That's units means already we discussed 1 kilowatt hour is equal to 1 unit. Means at that time the energy will be expressed in kilowatt hour. So in order to express in kilowatt hour, power should be taken in your kilowatt and time in hours. For example, suppose 3 bulbs of 50 watt for 3 hours. Second, 2 fans of 500 watt for 2 hours. and the cost of 1 unit. ठीक है, cost of 1 unit is ₹10. Then prepare the electricity bill. First find out for your bulbs. E is equal to P into T. What is your P? P is equal to 50 watt. Now you have to convert into a kilowatt. So divide by 1000 into time. Time is your 3 hours. Then this will be in your kilowatt hour. Whatever it will be. Next we have 3 bulbs. So you have to multiply this quantity with 3. That will be the total energy for the 3 bulbs. Clear? Suppose this is E1. Means energy for 3 bulbs of 50 watt each used for 3 hours. Then calculate the second one. Second one means fans. Use the same formula. E is equal to P into T. What is the value of your P? P is equal to suppose 500 watt. 500 watt. So divided by 1000, that will be a kilowatt into time. Time is your 2 hours. This is the energy consumed by a 1 fan. Now according to your question there are 2 fans. So you have to multiply with the 2. That is equal to suppose E2. Now find out total energy. Total energy is equal to E1 plus E2. Now you can find out E1, put the value of your E1 and E2. That will be a total energy. Means, for example, suppose this is 50 kilowatt hour. Means instead of kilowatt hour we can write down 50 units. So total energy consumed is your 50 units. Now in your question the cost of 1 unit is ₹10. So cost of 50 units is equal to how much? That is equal to 50 into 10. That is equal to ₹500. Clear? If there are other appliances in your questions, then the same process will follow. Means you have to find out the individual energy of different appliances. And finally you have to find out your total energy. Total energy means the sum of the energy used for each appliances. And at last you have to find out the cost of the electricity. Clear? So in this way you can find out the electrical energy, or you can prepare the electricity bill. But while preparing the electricity bill, we use the cost as per the slabs. So here first we discuss charge, then electric current, then current is related to potential or potential difference, and potential is related to your work done, and work done is related to your energy, and energy is related to your power. So all these quantities are linked with each other.